40 years ago marked one of humankind's crowning achievements, with the landing of a man on the moon and his safe return to Earth. Tragically, already then, the program and policy that had made such a dream reality and realized the greatest physical return on investment ever known was being dismantled. An overall identity shift turned the United States away from optimism in man's potential and the American system of economic development, towards an existential culture of sex, drugs, and rock and roll, and a British-directed economic policy of empire known as post-industrial globalization. Lawfully, the same cultural shift which destroyed the space program is directly responsible for today's global economic breakdown crisis. This crisis has demolished not only the legitimacy of the current dying monetarist system, but the entire mode of thinking associated with it. Just as the flat earth ideologues were wrong centuries ago, so too are those who today think that mankind is a species limited to the surface of one planet, scrambling over a diminishing supply of supposedly scarce resources. A fundamentally new notion of economy is required, one which embraces the policy of colonization and industrialization of our solar system, driven by man's natural propensity for exploration and discovery of the unknown, and fueled by what Lyndon LaRouche has proposed as a new Hamiltonian credit system, whose spin-off technologies and related scientific breakthroughs will, as history has proven, be more than adequate to meet the physical needs of a growing population of now nearly 7 billion people, at a standard of living never before achieved. But most importantly, will be the shift of national identity towards one of optimism and creative imagination. The German-American space pioneer Kraft Erika, who was instrumental in the early development of the U.S. space program, dedicated his life to elaborating the philosophy of what he called mankind's extraterrestrial imperative. At the dawn of the space age in 1957, he wrote,
"The concept of space travel carries with it enormous impact because it challenges man on practically all fronts of his physical and spiritual existence. The idea of traveling to other celestial bodies reflects to the highest degree the independence and agility of the human mind. It lends ultimate dignity to man's technical and scientific endeavors. Above all, it touches on the philosophy of his very existence."
Over the coming 2 generations, the industrialization and colonization of the Moon and Mars represent the outer bounds of the foreseeable social and scientific challenges for the United States, which, if met in cooperation with other nations, would represent a leap forward in the conscious evolution of the human species. Economic policies for space exploration are based on the same underlying principles as for those on Earth. Unlike monetarism, physical economy is based on the principle that there are no fixed limits to growth. While this principle is reflected in the highest degree in the form of human economy, it expresses a universal principle which is valid in both inorganic and living nature. Our relationship to the planet is unique. Unlike all other species, which live within the bounds of resources they find naturally around them, we survive and grow by using resources faster than they are naturally replenished. Contrary to the environmentalists, however, the difference lies not in our overuse, but rather in our creation of resources. The transformation of an economy powered by food for human and animal labor, to wood and then charcoal for heating, to coal and coke for steam power and metalworking, and into unlocking the power of the atomic nucleus, points to the true resource in human ecology, the creative power of reason which separates us from the beasts. The laws of thermodynamics state that there is a fixed quantity of energy in the universe, but with each fundamental discovery, we develop qualitatively new forms of power. Rather than amend these laws, we should repeal them. While there are hundreds of naturally occurring atomic isotopes, human beings can create and utilize a virtually unlimited number of new isotopes, each with unique properties adding new degrees of freedom to human economic practice. So far, we have largely depended on existing deposits of mineral resources already concentrated by the action of the biosphere, a physical investment cost that we have been able to ignore. Now, the development of nuclear fission and soon fusion give us the ability to overcome our accelerating depletion of the relatively richest concentrations of mineral resources, both by applying very high energy flux densities to extraction and refinement, and eventually through the synthetic production of economically useful elements by transmutation. We also improve the productivity of the biosphere in a uniquely human way, an activity which will represent one of the primary infrastructure costs of maintaining a decent standard of living, costs which will be supported by the increasing ratio of scientifically productive workers. The discovery of nuclear science early in the last century represented a new phase in the evolution of what Russian biogeochemist Vladimir Vernadsky termed the noosphere. Vernadsky recognized that the energetic activity of life, powered by the sun, which had created the atmosphere, oceans, and the increasingly complex flora and fauna of the biosphere, also created the preconditions for a more powerful geological force to emerge: creative man. Just as the biosphere has developed to higher states of power, so must we. Only by refusing to develop along this natural pathway, only by renouncing our character and regressing to a lower level of existence, will we undo the developmental work of the biosphere and destroy ourselves. But the biosphere is not an isolated system. Far from being an unlikely accident in a small corner of the galaxy, life on Earth is a cosmic phenomenon. Not only are all living organisms either directly or indirectly dependent on the radiant energy of the sun, but the entire space surrounding the planet is permeated with cosmic radiation and other highly structured electromagnetic phenomena, which condition the development of organisms and their environment, and may well play an important role in the evolution of species. We cannot fully understand this dynamic cosmic environment without extending our reach further into space.